In this video lesson, we're going to learn about hydrates, and we will learn how to determine how many water molecules are attached to a hydrate. A hydrate is an ionic compound that crystallizes with water molecules bonded to it. So when it forms its crystal structure, it isn't just the formula units of the ionic compound, there are water molecules interspersed as well. So some common examples of hydrates would be copper 2 sulfate, pentahydrate, so 5 water molecules attached, and copper 2 chloride dihydrate. It'll be different numbers of water molecules that attach. Now the term anhydrous means that these hydrate compounds that no longer have water molecules attached to them. So we can actually heat these substances and evaporate off the water molecules and then compare the difference in mass before and after to find out how many water molecules combine per formula unit of the ionic compound. So when you're calculating the molar mass of hydrates, because they always combine with the same number of water molecules, you have to incorporate the mass of the water molecules too. So these molar masses will be quite large because of the number of water molecules attached. So we'll go through an example of how you would determine the number of water molecules with this example. So it says a hydrate of barium hydroxide, BaOH2, and then we write a dot like this, XH2O, is used in an experiment. 50 grams of barium hydroxide, XH2O, has 27.2 grams of barium hydroxide. So the question is, what is the mass percent of water in this compound? And then what is X? So first of all, we'll have to figure out the percent composition of barium hydroxide and water, and then we have to calculate what X is. So our first step would be to find the percent composition of water and of barium hydroxide. So the information that we've been given, we know the mass of the compound, and that is 50.0 grams. We know the mass of barium hydroxide, and that's equal to 27.2 grams. So the first thing we'll do is we'll find the percent of barium hydroxide and then subtract to find the percent of water. So the percent by mass of barium hydroxide is equal to 27.2, I'll just erase that, 27.2 grams out of the 50 grams, so it's going to be just over 50% times 100, and that's equal to 54.4% barium hydroxide, and then the percent by mass of water is equal to the 100% minus 54.4, which is equal to 45.6%. So that's the first step you have to do when you're solving these types of problems. So you find out the percent by mass of the compound in the water, and then you find the percent by mass of the water alone. And then after that, we're going to take that and solve for the empirical formula. Just like you would do with empirical formula, we will find out how many water molecules are attached. So the next step we need to do is find X. So we can use the same method to find X as we do for empirical formula. So first of all, we need to know the molar masses of each. So we need to find the molar mass of barium hydroxide. So that's equal to, the molar mass of barium is 137.33, and there's 2 oxygens, so we'll put that in, and then there's 2 hydrogens, And we'll add that all together. So 137.33 plus 32.00 plus 2.02. The molar mass is 171.35 grams per mole. And now we'll find the molar mass of water. So that's equal to 2 times the molar mass of hydrogen plus 16.00 grams per mole. So that's 18.02 grams per mole for water. So now we can start putting this information in our table. So our polyatomic ion is the first one, barium hydroxide. And from the first example, our mass was 27.2. Our molar mass is 171.35 grams per mole. And I'll just put the information about water in right now too. So water, its mass was 22.8 and its molar mass is 18.02. So now we'll find out the moles of each. So 27.2 divided by 171.35. So we have 0.1587 moles. And the other one, 22.8 divided by 18.02. We have 1.2652. So now we'll take our moles and divide it by the lowest moles. So that would be the moles of barium hydroxide. So this will be 1. And the other one will be 1.2652 divided by 0.1587. We get a number that's like 7.97, which is equivalent to 8. So we now know our X value, so it's 8. So the way you would write this formula would be barium hydroxide, then this dot, and then 8H2O. So we'll work our way through a second example. So this time we have a hydrate of cobalt 2 chloride is used in an experiment. 70 grams of cobalt 2 chloride XH2O has 38.2 grams of cobalt 2 chloride. So the question is, what is the mass percent of water in this compound, and then what is X? So we have to do the same format as the last time to figure out the amount of the hydrate. So the first thing we need to do is find out the percent by mass of cobalt chloride and water. So the percent of cobalt 2 chloride is equal to 38.2 grams in the total mass of 70 grams. Times 100. So it is equal to 54.57%. And then the percent of water is equal to 100 minus that. That's equal to 45.43%. So now we can take that information to figure out the percent composition, or the formula of the hydrate. So before we can put our information into the table, we need to find the molar masses of each. So the molar mass of cobalt 2 chloride is equal to the molar mass of cobalt, 58.933, plus 2 times the molar mass of chlorine. And that is equal to 129.83 grams per mole. And then the molar mass of water is equal to 2 times the molar mass of hydrogen plus 1 times the molar mass of oxygen, which is equal to 18.02 grams per mole. So now we need to put this information into our table. So we have the first one, our polyatomic ion is cobalt 2 chloride. We call them polyatomic ions. And then water is just a group of atoms together in this case. We had 38.2 grams of cobalt 2 chloride and 31.8 grams of water. The molar mass of cobalt 2 chloride is 129.83. The molar mass of water is 18.02. So now we can find the molar amounts. So 0.2942. And then for water, it's going to be more than 1. .7647. So now we'll divide by the lowest amount. So this one is the lowest amount. So this one's going to be 1, and then the other one is going to be, so we've got 1.7647 divided by 0.2942. So 5.99, which is equal to 6. So therefore the value of x is 6. So our formula is cobalt 2 chloride 6H2O. And that's how you determine the hydrate for a compound.